So caves, arches, stacks and stumps. So if we imagine we've got a cliff. We've already talked about cliff formation. If you're not sure, there's another video that you can watch to go through this. We've got a cliff. And it's sticking out into the sea. Now, the sort of rock that the cliff's made up of will often determine how well it forms caves, arches, stacks and stumps. Some rocks are better jointed and faulted than others. So if we take an example of sedimentary rocks, for example, something like chalk or limestone, they often have faults in them, which are like fine cracks in the rock. Now, if this cliff has got faults in it, then those faults are very likely to become exploited by the erosive power of the waves, and they might start to widen over time and form caves. So you might have a series of caves along this coastline. If that continues and the erosion widens out that crack and that cave even further, then it's going to become bigger and bigger over time. Now, it might be that this particular cliff here is a headland sticking out into the sea, and actually the other side of it is just sea as well, in which case if that erodes all the way through and it gets bigger and bigger, you could end up with an arch. Now, this arch would probably be eroded at the base from the erosion process of the sea, like hydraulic action, where you've got the water pushing air into slight cracks in the rock. It could be weathered from above as well. What it's not likely to be is eroded beneath the water. So often arches, they're not very deep underneath because they're not really eroded below the low water mark. Over time, if this arch gets bigger and bigger, and we're talking about a long period of time, but if it gets bigger and bigger, this bit at the top here is going to become quite heavy, and it's going to be difficult to support any of that at all. Now, if that happens, what it's going to do is literally collapse into the sea. Now, if that happens, you're going to end up with something that looks a little bit like this. Here, rather than having the arch, you've got the actual cliff itself, and then you've got something called a stack at the side. Now, the stack and the cliff itself, they're all going to continue to be eroded. And we talked before about how you're going to have a high water mark and a low water mark, where the tide comes in and out. So this area at the bottom here is going to become attacked, and therefore eroded and eroded until that too actually becomes too thin to support this weight of rock above it. If that happens, the whole thing is just going to topple over. And if it topples over, you're going to end up with it on its side. Now, sometimes some of that will get washed away quite quickly because it's going to crack away from the main stack that was there. And it might be that you end up with a stump of land that's quite resistant and just staying there, something like this. And that now has gone from being just a fault in a rock to a cave, to an arch, to a stack, and to a stump. There's some really cool examples of these around the UK coastline, especially if you go down to Dorset. Old Harry Rocks, some fantastic examples of these kinds of landforms down there. Recap questions. Question 1. In this video, in what order did the landforms form in? In this video, we've looked at the formation of caves, then arches, then stacks, and then stumps, and they do tend to follow that progression. Question 2. Why does an arch turn into a stack? Arches turn into stacks because the weight of the roof of the arch becomes too heavy to be supported by the rest of the cliff, and so the roof of the arch falls in. Question 3. How do stacks become stumps? Stacks become stumps because they are tall structures that are undercut at the base by the action of the sea and the waves, and therefore over time the structure becomes too top heavy to be supported and it topples over, leaving a stump in the sea below. I think that's it for caves, arches, stacks and stumps.